So we now begin the sessions for last module. In fact, this is not in sequence, but looking at the theme of the subject, sometimes rather than understanding theoretical concepts, we understand applications first. That's what means. If you would have started thinking how computer works and then I will start programming, then you will never understand. It will take so much time for you. By that time, the technology must have gone much ahead. Therefore, what we do, I think I have provided you few recorded sessions. I am sure that you must have viewed them. Additionally, I will provide few more recorded sessions for fundamentals of sequential circuits, which also you should go through. So today's is just introductory session, wherein I will address the rationale for understanding this microprocessor, which is now stopped by Intel from manufacturing. Then still, why it is there the syllabus? The reason is quite simple. It happens to be very easy processor to understand. Now, listen very carefully all the things. You also go through videos already put to you and which I will be putting today. Whether few of you were there having 12th vocational as computer science, so for them 85 they must have studied. But the manner in which it is explained is something which is difficult to understand. So if you go through my recorded sessions, you will find that the purpose is understanding. And now we study hypothetical 885. Hypothetical means few changes I have deliberately made in the structure of that process, because that is no longer existing. So it is a model which we want to study. Now this subject is quite important for you, which will be discriminating you from other professionals who use computer. Say now we are having many people who are non-STEM, that is not even science and engineering, not forget about engineering, not even science background, but they still use computer. So using computer for some preliminary data processing operations or for using some tools is just a skill and not knowledge. No knowledge, no analysis is involved there. But when students of an engineering college look at the computer, there has to be an entirely different approach. So it is said that three major inventions which have revolutionized the world. The first was invention of wheel. It is in ancient days. When wheel was not there, it was very difficult to have movement. Invention of wheel. Then for years together it continued with the power being in live, used either by the man himself or live animals, bullock carts and all these things. But when current electricity came, IC engines and electric motors were parallel, so both can be said to be simultaneous. That is what we can say, power being derived from non-living entities in the form of IC engines and electric motors. Or invention of electricity is second thing which brought tremendous changes. And the third is in recent past, that is invention of microprocessors in 60s. That has completely revolutionized the world. But now you would be surprised. Have you heard of the fellow von Neumann? What is his contribution? What he said? Von Neumann has envisaged a computer architecture or an architecture for a microprocessor based system in which year? In which year? 1945. When even what was not invented? Transistor was not invented. When even transistor was not invented, that time he has envisaged about the microprocessor architecture. What is his architecture? He said that there will be a machine which will be able, what that architecture is? What is it? That very famous von Neumann architecture. Von Neumann envisaged is about the CPU. So that time concept of address lines, data lines and memory means somebody would have said that so much size of memory, are you fool? Where from I get it? Because those days computers were comprised of very heavy electromechanical devices of the size of this room. A CPU which with the help of address bus, data bus and control bus will be able to access a memory which contains program plus data. Von Neumann has thought, what are you doing? You are searching von Neumann architecture? Look here. So in the classroom, everybody has to look at the whiteboard to ensure that you are concentrating on this subject, but you are at liberty to look at the whiteboard and think something else, which I can't verify. But by ensuring your eye is focusing on the whiteboard or that smartboard, as the case may be, what I try to ensure, I try to reduce the probability of distraction. I can't eliminate it to zero. So a CPU. Now, we are in the world of AI. So at today's age, how human beings should think. Von Neumann has thought of computer without using computer. A computer engineer need not require a computer to work. Pen, paper and mathematical mindset, you should be able to work. Just like von Neumann. Is the idea clear? Computer is not, without computer, you should be able to have a complete logical frame of what you think, what the thing should be. Now, you must have studied basic electrical and electronics engineering. In that, where the gates and all these things were there, logic gates. So, digital circuit you have studied. Whether flip-flops are there? Yeah. Flip-flops? Memory elements? No. Flip-flops are there, right? So everybody knows flip-flop? See now, I will ask a simple question which I am sure that nobody will be able to answer. And from there, because the flip-flop is basic memory element. Flip-flop is basic memory element, and from there we will find that a memory element, a combination of multiple flip-flops, some memory which is permanent, some memory which can be rewritten, and some kind of other complex. Ultimately, what is microprocessor? It is digital circuit. Arduino it may be microcontroller, it may be Intel huge microprocessor. Ultimately, it is a digital circuit. Then the question is, how this digital circuit is different than other digital circuits? This is depending upon the program which resides. This digital circuit is, in fact, have you heard about finite state machine in some of the other subject? Finite state FSM? If not, then search on Google. So, this digital circuit This, you must have seen running light on an LED display board. You see various combinations. So, and they occur in some sequence. And there can be many ways in which they can occur. Ultimately, a digital circuit is having a state. When input lines are there, output lines are there. Output lines, when there are n output lines, they will produce n combinations. One combination, next combination, next combination. And like that, there can be infinite combinations you can construct. This microprocessor based system is of different kind than a conventional circuit like timer, etc. Means the circuit now microprocessor based is a different classifier. Now just like you can say AI enabled thing and non-AI enabled. Few years back in India, those who are literate and illiterate. Then it came digitally literate and digitally illiterate. Now among digitally literate, the theme is coming as AI literate, AI illiterate. Like that in systems, microprocessor based systems and non-microprocessor based systems. Like that things are there. So now just to today this introductory session, I would not like to engage much because anyway that ambience is not also so fine. But I will ask you a important question which I am sure that you will not be able to answer. And if I am proven wrong, I will be very much happy. So the basic of microprocessor is a bit, right? Bit, then byte, and then multiple bytes in memory. So a bit is everybody words 16 bit now, 32 is also gone back much back, 64 bit, 256 bit, and in terms of memory capacity, mega is has gone back now, giga is there. After some time tera will come. Is it right? So what is the basic entity of it is a bit. A bit. What is a bit? It is a binary variable which can have two states. So bit, and it can be remembered. So flip-flop is the basic building block of that. Now I would like you to answer the simple, most simple question. Complete the truth table for this flip-flop. A and B are its inputs. Is the question clear? Most simple digital circuit. NOR gate everybody knows. For OR gate, when any of the input is 1, output is 1. And for NOR gate it is reverse. If any is 1, output is 0. So complete find the answer. What happened? What happened? Anybody finished? Nothing is difficult. It's the most simple circuit. Are you prepared the attendance? So what will happen? When for a NOR gate, logic high or 1 is said to be a decisive state. Means what? If any of the input is, if one of the input is in decisive state, then other input need not be looked into. Right? Logic 1 is a decisive state for NOR gate. Means what? If any, you know only one input, and if that is in decisive state, then irrespective of other input, output must be 0 or 1. For NOR gate, एक इनपुट 1 असेल तर आउटपुट काय पाहिजे 0 पाहिजे. So what parts you can complete in this truth table without bothering much? Anybody finished truth table? Yes or no? You finished? हे बरं घेतलं का नाही? Was it taken in the class? Or you don't remember? घेतलं का नाही? Flip flop. Finished? Yes or no? You need to finish or not? जर एक जरी इनपुट 1 असेल तर त्याचा आउटपुट 0. म्हणजे ऍटलीस्ट यातले कुठले पार्ट पूर्ण करता येतील? 4 ठिकाणी ते 1 आहे. Look at the top gate. Whenever A is 1, C must be any confusion? No. So wherever A is 1, put C as 0. For the lower gate, wherever B is 1, put D as 0. It's not. Sorry. I see. Okay. Anyway, but ulte यार पढ़ना काहीतरी. It's both NOR gates. Both NOR gates. So whenever A is 1, C is 0. Whenever B is 1, D is 0. Now, next. What about C here? What about D here? Let us talk about this. A is 0. So when A is 0, you can't immediately conclude about C. Are you getting me? 1 is a decisive state for the NOR gate. So when A was 1, there was no problem. But when A is 0, you can't conclude. You can't conclude means it's not that you can't solve. To conclude, you need to know this input. Right? So at this point of time, what is A? A is 0. So for this top gate, what is the second input? That is D. Right? What is D? 0. So both inputs 0. For OR gate output is 0. For NOR gate output is 1. And here for lower gate B is 0. The other input is C. C is 0. So this must be. Is it right? Is it okay? Now here, if you are able to solve C, this is the computer science students of this college are top 5th in Maharashtra. VJTI, COEP, PICT, SPIT, then Walchand CS. So this everybody must be able to solve so as to deserve your ranking. Okay. What is the difference between sequential circuit and combinational circuit? Anybody knows? Flip-flop is a combination of sequential circuit. Adder क्या है? Combination. Flip-flop. What is the essential property of sequential circuit? It is having no. In construction, there is one condition which must be met. What is that? There must be memory. See now, flip-flop itself is memory. Flip-flop मध्ये memory पाहिजे याला meaningless statement काहीच अर्थ नाही. So when you can say a circuit to be a sequential circuit, whether gate is a sequential circuit, only gate no. So you connect multiple gates. So multiple gates you connect. Using multiple gates, you can get a combination circuit. Using gates you get adder, XOR gate and AND gate you get adder, half adder, then full adder. Then to get a combination, to get a sequential circuit, again gate is a basic element. Actually entire digital circuit is built up upon gates and one more, that is tri-state buffer. In my whether anybody has gone through my videos, 18 videos of average 40 minutes. So gate and tri-state buffer is very important thing. See, if this you understand very clearly, then irrespective of Intel or its competitors, whatever higher version of microprocessor they may develop, you are having a crystal clear idea of what the things cannot be. म्हणजे हे एकदा कळलं की जगातला कुठलाही सर्किट मायक्रोप्रोसेसर तयार करायला तो याच्या पलीकडचा काय आहे. आता द थिंग इज नाउ इफ यू think to understand everything what it is, it will be impossible for you. So what you must be able to understand, a new thing. It cannot be beyond this. मला हे एकदा कळलं की जगातलं काही नवीन जरी केलं तरी ते कशाच्या पलीकडचं असू शकणार नाही. एवढा अंदाज जरी मला आला तरी बाकी सगळं कायचा अंदाज याची गरज नाही. Today, if you means hard work does not have that much significance than that of smart work, because if a very sincere student, if he starts reading everything, he will be lost there. He should be smart enough what to read, what not to read, what to understand, what is not required to be understood. So gates, tri-state buffers and their combinations is entire digital circuit of which microprocessor. And now just to explore further, do you know, can anybody tell me what is computer system? You know, what is AI based system and non-AI based system? Or what is AI enabled microprocessor based system and what is non-AI enabled microprocessor based system? What can you differentiate? What is AI based? It's ultimately microprocessor. It's a computer. So a conventional program and AI based program, what is the difference? What is the difference? You may be using generic AI, supervised learning, non-supervised learning, deep learning, rather than these jargons you don't understand them. A simple question. What is AI based, AI enabled system and conventional system? क्या फर्क है? AI based program and non-AI based program, what is the difference? What is the difference?
AI-based programs can change on their own. They can take decisions on their own.
And other one?
They have to be manually updated. Or
Decision on their own means what? How it can be? See now, don't you think it's a wonder how? Don't you think that Means you should ask the first question, how it can be possible? It's impossible. Hmm?
On the basis of data.
On basis of
Data.
data. So you are coming close. What is the difference? For a conventional computer, if some task is assigned n times, each time it will take same time. Where for AI based system, it is just like human. If I have to walk through unknown area, for the first time I take time. But रस्ता सवयीचा होणे हे जे थीम आहे. As I am frequent, I do it fast. So, AI based system will carry out the task if when it is doing multiple times at a in lesser time at a higher speed, because it depends upon one numeric we said program and data. The program depends on some data which is there in the memory. Actually, then you said data, then is it a data? This is a blank board. In digital, there is nothing like blank. Every element is there, one byte. Each bit is either 1 or 0. Are you getting me? Digital मध्ये blank असत नाही. Even if you have not stored anything, by default, it is either. So always data has to be there. Now how AI can use it? Or what is the difference in AI? AI based program is such program which depends, it is in a way recursion in different context. The program refers to a data set while running, and during running it updates the data set. So initially data set is there is random. Initially it's a random data. So when working on random data it takes more time, and then it modifies the data. So next time it is a suitable data, and based on that it takes less time, again it modifies. So a program which depends means a recursion in different sense. Program depends on something which it modifies. Are you getting me? What is in a single word, sentence, if somebody asks you what is AI based system? AI based system is a program which depends on that set of data which is modified by itself. Is it clear? So this is the thing which is very much important. So in the sequential circuit, feedback is essential for memory. Here there is a feedback. So a memory like thing comes. Now you tell me, as regards to input-output relationship between combination circuit and sequential circuit, what is the difference? There are set of inputs, there are set of outputs. For a sequential circuit and for a combination circuit. For a combinational circuit, for a given input combination, a given input combination leads to a unique output combination for a combinational circuit. Where for sequential circuit, a given input combination not always, can lead to multiple output combinations. Now, you are still puzzled here. Prior to that, I will ask another simple question which I am sure that you must not have come across at all. Can you write the truth table for this? Most simple circuit, OR gate, output coming back to input, A is other input. So what is the truth table? When A is 1, Y is 1. So that anybody can write. And when A is 0,
Depends on.
depends on, means we can say 0 or 1. If it is means A equal to 1 is having unique output state, but A equal to 0, it can be 0, still it's okay. It allows one-to-many combinations. 1:1 mapping is in combination circuit. There is either 1:1 or many:1 mapping. But in sequential circuit, there can be 1:many mapping also. Given its same input combination, there can be multiple output combination depending upon what was previous state. Right? This is a consistent sequential circuit. And now what I am drawing next? Can you answer now? It's very difficult. What is the answer? See how they are busy in thinking, so they are not having any attention to you. What is the answer? 1 is simple. When A is 1, Y is, that anybody can answer. Now, so in previous case, can I say like this? In previous case, can I say that is it right? In previous case, A is 1, Y is 1, A is 0, Y is Y. Right, na? 0, Y. So this is 0, this is Y. 0 plus Y equal to Y. That is Y is 1. Right? And now what happens here? It is Y, it is Y bar, it is 0. 0 plus Y bar is Y bar and again bar. So what it is? What we get? This is Y, this is Y, this is Y, right? 0 plus Y is Y and output is Y bar. So can I write like this? Is it okay? Is it right? You can start thinking. If A is 0, and let this be 0, so what will be the output? 1. Let this be 1, what will be the output? A is 0. So if this is 0, output is 1. If this is 1, output is 0. So this is inconsistent. So what the output would be in actual case? If I connect like this, what will be the output? So this is a consistent sequential circuit. One input, multiple possible consistent states. One input for for A0, right? For A1 no issues. In the first circuit, for A1 output is 1. For A0, output can be 0, output can be 1, but these are stable. So multiple consistent or stable states. And for this, if A is 0, output can be 1, output can be 0, but if it is 1, listen very carefully, 1 output will not allow to remain 1. It will make it 0. 0 output will not allow it to remain to be 0, it will make it 1. So what actually I will get? If I actually construct the circuit, what I should get logically here? Now this is a physical system which takes some time. So what the output should be? It should become 1 for some time. It needs sensing. When it senses 1, output will become 0. For sensing it takes some time. So it will be a square wave. Output will be a square wave and the frequency will be depending upon the speed of the gate. Fast gate, high frequency, slow gate, low frequency. This is a inconsistent circuit with feedback. Normally not used for clock generation. But it is a consistent circuit. Now what will happen here? What happened here? Now you might be in COVID time appear for some MCQ tests. Or for CET there were MCQ tests. So in conventional tests you have to find out. As an MCQ test you have to guess. So in digital everything is MCQ. Because combinations are finite. What is asked? What is the question asked here? Draw the truth table. A and B are given, C and D have to be found out. Then what will you do? Yet we are unable to find out. Then if it's a routine question which has infinite answers, you can't do. I will assume this, check this. I will assume this, check this. That you can't do because there are infinite combinations. But here there are how many combinations? Finite combinations. So you can check each combination and if yes, whether it will remain or it will not remain. So let us start with output as. We start with output as. Let's assume that C and let C be equal to and D be equal to 0, 1. What happened? If I assume C as 0 and D as 1, A is 0, B is 0. So when A is 0, B is 0, can you write a simple equation? A is 0, B is 0, 0, 0. So what is this? So for this 0, this 0. So for this gate, what is the input? D. And what is the equation of this gate? C equal to this 0 plus D bar. So C equal to D bar. And for this gate, C is the input, D equal to C bar. So C equal to D bar is the equation. So C equal to D bar is satisfied by two states. What are those? C0 D1 or C1 D0. So if you assume that 0 1 or 1 0, what will happen? For both cases it will remain stable. This flip-flop will give me output either 0 1 or 1 0. What exactly depends upon how you are traveling. If I assume input as 1 1, what will happen? If I assume input as 1 1, what will happen? Sorry, not input. If I assume output as 1 1, it can't sustain. If output as 0 0, what will happen? If it is either 0 0 or 1 1, it will. Do you know state transit diagram in some subject, discrete or some subject? Do you know it? State transit diagram? Don't know. 0 0. What are the four states? 0 0, 0 1, 1 0, 1 1. So 0 is a stable state. You can remain there forever. 1 0 is a stable state. You can remain there forever. No problem. If you change input, from 1 0 you can come out. From 0 also you can come out. But 1 1 you can't remain at all. 1 you can't remain. So from 1 1 you either, and 1 1 you can't enter also. In 0 0 you can't remain. You can come here, you can come here. But in 0 0 you can remain if this is 1. So input 1 1, output 0 0. Input 0 1, output 1 0. Input 1 0, output 0 1. There is no input which can bring it in 1 1 state. 1 1 input can keep it in 1 0 0 state. From 1 1 if I change to 0 0. From 1 1 if I change both inputs to 0 0, what will happen? लक्षात आलं का? Earlier both inputs were 1 1. So both outputs were 0 0. So I make now both inputs as 0 0. What I will end up? Either 0 1 or 1 0. And what exactly depends upon the construction of the flip-flop, which is passed. This is called as which condition? Race around condition. In many books, what is written here? So, if from this state I try to go to this state, then I will end up here or here, I don't know. This is race around condition. To avoid this race around condition, this state is forbidden. Forbidden हे 0 0 कंसात द्यायचं असतं. तिथंच forbidden द्यायचं नाही. If you in many books you find that in 11 12 books also, forbidden is written in the truth table column. So you find that something which is I can't answer. It's not like that. When both inputs are 1 1, both outputs become 0 0. It is well defined state. This state is banned because if from this state you try to go to this state, what the output would be you can't predict. Therefore this state is banned. And once you ban this state, then what you can say, that if you are having 0 1 and make it 0, output remains 1 0. If you were earlier 1 0, make this 0, output remains 0 1. And when you ban this state, both states are permissible. That is last state. Last state means what? If last state was 1 0, means if inputs were 0 1, last outputs were 1 0. If inputs become 0 0, last state continues. If inputs were 1 0, last outputs were 0 1. If you make now input from this 1 to 0, last state continues. Last state means both are permissible. That is 0 1 or both are permissible. 0 1 or 1 0. I hope it is a very concentrated dose. We stop here.